Okay, so I started, dang. Okay, let's come up here. Hello. It's your algebra unit 7 test review. This is your teacher, Mrs. Nagel Perkins. Welcome, so glad you're here. I started a minute ago and then I realized I had to put that key on the bottom, so then I stopped and I put the key on the bottom and then I started again, and then you just saw it, but it's at the bottom. So let's go ahead and let me apologize for this review, which had many mistakes, and I just am all discombobulated. New favorite word? Hey. Okay, so number one, first of all, we're factoring. We're not doing equivalent. So let's just go ahead and say, let's factor, because that's what we've been doing. So since we're never, ever supposed to have a negative in the leading coefficient, which would be right here, I'm going to take my polynomial and I'm going to divide by -3, which if you notice over here, my answer choices all had 3. So I'm going to go ahead and just factor out a -3. I end up with x squared minus 8x plus 15. This is what I'm going to factor. So when you look at that and go, oh, look, B's the answer. B's not the answer because I'm factoring. So sorry if you picked B. My sum is -8. My product is 15. Things I can multiply 15 by are -5 times -3, which equals +15, and -5 plus -3 equals -8. So if I put those in my box, I have x squared in the top box. I have 15 in the bottom box. I put in my magic numbers, and it doesn't matter where I put them. I'm going to put my -5x up here and my -3x down here. Now I'm going to look for a new color because I can. Okay, I'm looking for my greatest common factor here, which is going to be x. My greatest common factor down here, which is negative because this is negative, and 3 is my greatest common factor. I'm looking for my common factor on the left side going up and down, and that's going to be an x. I look for my greatest common factor going up and down on the right, and that's going to be -5 because that's negative right there. And I end up with x minus 3, x minus 5, and the -3 in front, which makes D the correct answer. Okay, number 2, I'm going to do with the, I'm going to do it the other way. I'm going to put in my magic numbers and then find the greatest common factor. 4-term grouping is what it's called. But first I'm going to change my equation to x squared minus 5x minus 36. And I'm going to find that my sum is -5 and my product is -36. So the factors of -36 that would add to -5 are going to be -9 and +4. Because -9 plus 4 is -5 and -9 times 4 is -36. So I'm going to take my -5x and I'm going to blow it up into my magic numbers. My x squared stays and my -36 stays. But instead of -5x, I'm going to write -9x plus 4x. And then I'm going to find the greatest common factor of each one of these two. For the left side, it's going to be x. For the right side, it's going to be 4. And when I divide by x, I'm going to end up with x minus 9. And on the other side, I'm going to end up with x minus 9, which is what I want to have happen. So x plus 4 is one of my terms, and x minus 9 is my other term. So my answer is A. We're just going to make this a whole mess of colors just because I can. Okay, number 3, I also made a mistake. And the H should have been at in the middle. So let's have -x squared plus 8x plus 9. Again, we have that leading negative, which we do not like. So I'm going to divide everything by -1, and I end up with x squared minus 8x minus 9, which means that the one of G or H are going to be my answers. My sum is -8. My product is -9. If I find two factors of -9 that add to -8, I'm pretty sure it's going to be -9 and +1 multiplied to -9 and add up to -8. So I'm going to make my box. I'm going to put my x squared top left, -9 bottom right. My magic number's in the middle, so I'm going to have -9x plus 1x. Looking for greatest common factors, x on top, -9 on the bottom. And then left and right, I'm going to go in my columns, x on top, and 1. So my factors are going to be x minus 9, x plus 1, with a -1 in front, so H is the correct answer. Okay. Okay, for number 4, when we are talking about difference of two squares, we are talking about perfect. First of all, it has to be perfect squares. That was supposed to be a 1. It has to be perfect squares. And it has to be subtraction. Hence the difference and squares. So if I'm looking at these choices and I know 81 is a perfect square and 4 is a perfect square and it's subtracting, that one is. 2, not a perfect square. 16, perfect square, doesn't matter though. 2 is not a perfect square. Everybody remember that, I hope. Oh, which means I picked the wrong answer anyway. Number 3 is wrong because it's an adding problem. Number 4 has two perfect squares. 36 is a perfect square, 49 is a perfect square, and so my answer is B. So all you have to remember is these things. Anytime it says something about squares, if it doesn't have perfect squares on the either end, it's not going to be a perfect square problem. Okay. Number 5, I'm going to factor out an x and end up with, I'm going to factor out a 5, and I end up with -13x plus 9. Since that doesn't look like any of my answer choices, I'm going to factor out a -1. So I end up with 13x minus 9. All this gets added, multiplied together, so I end up with -5x times the quantity 13x minus 9, which makes our answer A. Okay, so number 6 is also one of those perfect squares. It's not the difference though, but it's a perfect square polynomial. This is a perfect square and this is a perfect square. So I'm going to assume that it's a perfect square polynomial, and I'm going to check it by writing the factors and then seeing if they turn into one of these answers. The square root of 100 is 10. There's a minus sign right here, so they're both going to be minus. Square root of 16 is 4. I look at these two right here. -4 times 10 is -40, and I double it, which gives me -80. So this is correct, and my answer is G. Some of y'all were working on that and trying to make it into put it in the square and find the magic numbers and factor out a 4, and all that works. but you don't need to because hopefully you see, oh, look, it's a perfect square trinomial. So that's the only way I'm going to work it. Okay, so number 7, let's talk about the difference of two squares again. 16 is a perfect square, 1 is a perfect square, there's a subtraction in between, so I'm pretty sure it's the difference of two squares. Square root of 16 is 4, and the square root of 1 is 1, and when it's the difference of two squares, 1 is adding and 1 is subtracting. So if you notice the difference between number 4, well, we didn't do it though. Okay, never mind. Number 6 had the factor in the middle, the term in the middle, and it ended up with both of the binomials having the same sign. When it's a difference of two squares, there is no term in the middle, and you have one that's a minus and one that's a plus. So that's the difference between those two things. Okay, number 8. It looks like a perfect square trinomial because 9 has a perfect square and 16 has a perfect square. But like I said before, if you go ahead and factor it, you have 3a and 3a, and the square root of 16 is 4 and 4, and there's both additions, so we're going to put plus. And then if you multiply 4 times 3 and double it, you don't end up with 8, you end up with 12 and 24. So you end up with 24. So this is not the factoring of what we have right here. So something needs to change to make it a perfect square trinomial. So the first thing it says to do is add 9 to the 16. So that would make it 9a squared plus 8a plus 25. So again, we've got perfect squares at the front and the back. But when we do that, we change the 4, like when we were over here with that 4, changes that 4 to a 5, which is really going to make the middle number bigger, not smaller. So that one's not going to work out. And I could do, I guess I have room over here. 3a plus 5, 3a plus 5. 5 times 3 is 15, double it is 30, not anywhere close to my 8, so that's not going to do. Okay, so let's subtract 5 from the 9. That means we're going to have 4a squared plus 8a plus 16. This one would be 2a plus 4, 2a plus 4. This is 8, except that you have to double it, which makes 16. So it's not B. C is not a perfect square trinomial, so it's not C. So it's probably D, but let's check it. If we have 9a squared plus 16a, oh, plus 16 plus 8 makes 24. My bad. 24a plus 16. If we look back up here, what we were doing at the top, you're going to go, oh yeah, that works, because we have 3a plus 4 times 3a plus 4, and that is 12 squared, which makes 24. So that one is the correct answer. Okay, number 9. The easiest way to do this is to do your long division, which I know some of you guys totally hate, so I'll do it 2 different ways. First of all, thank you for changing this to a minus 10. And changing the x on the bottom to an f minus 3. So if I do my long division, and I write all this in here, then I look at my f, and I look at my 3f squared, and I think, what do I need to multiply f times to equal 3f squared? And it's going to be 3 and an f. So I'm going to multiply, I'm kind of going to distribute that 3f. 3f times f is going to be 3f squared. And 3f times 3 is going to be minus 9f. Since I'm subtracting, I'm going to change all my signs, including the second one, which I think is where you guys have trouble. My f squareds cancel out, and I have minus 10f plus 9f, which is negative 1f. Bring down my 3. And then I go, oh, f plus 3 and f minus 3. If I multiply my f times negative 1, then I would end up with negative 1f plus 3. And these are the same, which is going to give me a 0. And this is my answer, 3f minus 1. If you don't like to do that this way, and because there is no remainder, I should be able to take this and factor it and get f minus 3 as one of my factors and 3f minus 1 for my other one. So my sum is negative 10. My product is 9. Since it's positive, I could do negative 1 times negative 9, which would give me positive 9. And negative 9 plus negative 1 gives me negative 10. So in my box, I'm putting 3f squared. In the bottom right box, I put a 3. My negative 9f and my negative 1f. Looking for greatest common factors, 3f. Greatest common factor, because there's a negative sign right there, negative 1. Greatest common factor up and down is going to be f. Greatest common factor, negative 3, because the negative sign's on top. So here are my factors, f minus 3, 3f minus 1. So this would be the answer when I simplify. And just because I can, when we're talking about simplifying, I would basically replace this, f minus 3 times 3f minus 1. And if I divide that by f minus 3, these basically cancel out, and I'm left with this as my answer. Okay, number 10. So I have 27d squared, and it's reduced, means subtract, 147. I'm looking for a common factor because those are not difference of squares. Neither one of those is a perfect square. So I just happen to know that 147 is divisible by 3 because 1 plus 4 plus 7 equals 12. 12 is divisible by 3, so 147 is divisible by 3. Okay, 3 divided by 27 is 9d squared minus 3 goes into 14 4 times with 2 left over. 3 goes into 27 9 times. And they're going to be my numbers for my perfect square. So I'm going to write 3d minus 7 and 3d plus 7. And my 3 goes out in front. Here is my area. All right, number 11. Okay, we have a pasture. Woohoo! The area is this. And I'm going to factor that to find the 2 side lengths. And my sum is 11. My product is 28. Factors of 28 are 7 and 4, which add up to 11. So, and since I just made a box, I'm going to use my pasture for my box. X squared goes in the top left, 28 goes in the bottom right. And then my magic numbers go wherever I want them to. Greatest common factor on top, X. Greatest common factor on bottom, 7. Greatest common factor on the left side, X. Greatest common factor on the right side, 4. So my answer is X plus 7, X plus 4. Those are my dimensions. So now if I want to find the amount of fencing the farmer needs, I'm going to take my 2 sides and I'm going to add them together. So I end up with x plus 7, x plus 4, x plus 7, x plus 4. And if I add all those together, I have 4x plus 7 plus 4 plus 7 plus 4 is 22. Okay, here's another one of those problems where I can either do long division or I can factor. If I do long division, it'd be faster for me, but we're going to factor this. So the sum is -1. The product is 6 times 12 is 72. Yeah, 72. Negative. Okay, so I just happen to know that 8 and 9 make 72. And I need a -1, so my 9 has to be negative and my 8 has to be positive. So I end up with 6x squared plus 8x minus 9x minus 12. I take the greatest common factor of the first two terms, which is 2x, and when I divide, I get 3x plus 4. And on this side, I'm going to divide by a -3, which gives me 3x plus 4. Woohoo! Okay, so 2x minus 3 is my width they already gave me. So this is the length they're looking for, which is J. Thirteen is already in 4 terms, and so I'm going to go ahead and I just did 4 terms. I'll go ahead and put it in a box. So I get 2x to the third power in the top left, -6 in the bottom right, minus 3x squared here, and 4x here. Okay, greatest common factor on the top row is x squared. Greatest common factor on the bottom row is 2. Greatest common factor on the left-hand column is 2x. And the greatest common factor on the right-hand column is a -3. So my answer is x squared plus 2 and 2x minus 3. X squared plus 2 and 2x minus 3. So J is the answer. Okay, 14 said explain. So I'll do a short explaining, but we're going to factor. But before we factor, we're going to find the GCF of 3. And we're going to divide. That, and we end up with w squared plus 2w plus 1. And I happen to notice that I have perfect square trinomial because square root of w squared is just w and square root of 1 squared is 1. But I could do the box if I need to. Product is 1 and the sum is 2. So products, the factors of 1 are 1 and 1, which are going to make 2. So I'm going to have, w squared plus 1w plus 1w plus 1. 1w, so I have w plus 1, w plus 1. So after I took out my greatest common factor, I have w plus 1 times w plus 1. To do the volume of the box, I'm going to multiply my 2x times x plus 1. And I'm going to get 2x squared plus 2x. I'm going to take 2x squared plus 2x. And I'm going to multiply it times x plus 3. So I have double distributing. I have 2x. Well, I'll do a box. 2x squared plus 2x and x plus 3. 2x squared times x is 2x to the third. 2x times 3 is 6x. 2x times x is 2x squared. 2x times 3 is 6x. So I end up with 2x squared, 2x to the third. And then for this one, for some reason, we end up with our things to add together there. Plus 2x squared plus 12x is the answer. Okay, so number 16 was a complete screwed up problem. Again, what a surprise. Again, I apologize. I don't know what I was trying to do, too many things at one time. And really, you can't find the length when you have this equation. So what we're going to do is we're going to double 2x squared plus 5x plus 9. And we're going to have 4x squared plus 10x plus 18. Because that's going to be 2 times the length plus the width. So if I divide everything by 2, which kind of gets me back where I started, I can at least find the perimeter that way. So when I divide by 2, now I'm going to have 2x squared plus 5x plus 9 equals length plus width. So yes, I totally cheated just to make it work out so we could at least work the problem. Otherwise it doesn't. You get decimals and it's just not, it's ugly. Okay, so if the width is 2x minus 1, then I'm going to subtract 2x squared minus 1, which is my width, and I should end up with my length, which is 5x minus plus 8. So we're going to say that's the length. The width is this. So if I want to find the area, I'm going to do 5x plus 8 times 2x squared plus 1. I'm going to do my double distributing thing. I have 5x times 2x squared plus 1 plus 8 times 2x squared plus 1. So I end up with 10x to the third plus 5x plus 16x squared plus 8. I'm going to rearrange it to put it in descending order, and I'm going to end up with 10x cubed plus 16x squared plus 5x plus 8. That would be the area of that, whatever it is we're talking about, rectangle. Okay, hope that helped. Here is the answer key I promised. I didn't put the answers for 16 and 17 because we just changed that one anyway. But all the rest should kind of make sense as far as what we just did. But if you want to just check your answers, there they are. Hi.